A normal is a line perpendicular to the surface of the plane mirror. The line from the object, which in this case is the bug, to the intersection of the normal with the mirror is called the incident ray. The angle between the normal and the incident ray is called the angle of incidence. The incident ray reflects, and the reflected ray makes an equal angle with the normal, called the angle of refraction on the other side of the normal. If you change the angle of incidence, you will find that the angle of reflection matches it. Try dragging the 2 points on the mirror to different locations. You will notice that when you trace the reflected lines backward, they will intersect at a point where the image will form. The distance of the object from the mirror will be the same as the distance of the image from the mirror. Only 2 rays are required to obtain the position of the image. If you hold a symmetric letter like A in front of the mirror, you will not notice any difference. But if you hold asymmetric letters like F or P in front of the mirror, you will get an inverted reflection. This reversal is called lateral inversion. If you hold a laterally inverted letter in front of the mirror, it will appear normal. Ambulances are always in a state of emergency where they need to get a person to the hospital quickly. They display the word ambulance inverted laterally, so that when you hear the siren from behind and look in the rear view, the word ambulance would appear normal due to lateral inversion, and will yield way to the ambulance rather than struggle to read a laterally inverted word. A virtual image is one that is formed behind the mirror and hence cannot be captured on a screen. A plane mirror can form only virtual images, as they are always formed behind the mirror. The wall causes an obstruction and prevents the man from seeing the giraffe. The periscope works on the principle of multiple reflecting plane mirrors, which allow you to see over obstructions. The image of the giraffe gets reflected from the first mirror to the second mirror if the angles of both mirrors are positioned correctly. A concave mirror has a reflecting surface which bulges inwards. If the concave mirror is thought of as being part of a sphere, then the center of the sphere is the center of curvature. The line joining the center of curvature to the mirror is called the principal axis, and the point where it meets the mirror is called the pole. The focus is midway between the pole and the center of curvature. A ray passing through the center of curvature reflects back along the same line. Try changing the angle and you will notice that the reflected ray will always pass through the center of curvature. When an incident ray passes through the focus, it reflects parallel to the principal axis. When an incident ray passes parallel to the principal axis, the reflected ray passes through the focus. Any ray incident at the pole will reflect back at the same angle in the opposite direction. A ray striking the concave mirror at any point will reflect back at the same angle. Here, the normal will be the line joining the center of curvature to the point where the incident ray strikes. The angle of reflection will be the same as the incident angle. Drag the candle along the principal axis and you will see where and how the image forms. You can try placing the candle beyond the center of curvature, at the center of curvature, between the center of curvature and the focus, at the focus, and between the pole and focus. Note the cases where the image is inverted, magnified, and diminished. Also, pay special attention to how the image is formed. One ray is taken parallel to the principal axis, and that passes through the focus. Another ray is taken through the center of curvature, and that retraces itself along the same direction. The intersection of the two is the position of the image. Images can be formed in front of the mirror or behind the mirror. If they are formed in front of the mirror, they can be captured on a screen. The images that can be captured on a screen are called real images. The images formed behind the mirror cannot be captured on a screen and are called virtual images. Real images in concave mirrors are inverted and diminished. A convex mirror has a reflecting surface that bulges outwards. The nomenclature for the convex mirror is similar to that of a concave mirror. But one major difference is that the center of curvature of the convex mirror does not lie in the reflecting portion, whereas in a concave mirror, it lies within the reflecting portion. A ray passing through the center of curvature reflects back along the same line. Try changing the angle, and you will notice that the reflected ray will always pass through the center of curvature. Note here that the incident ray bounces off before it can touch the center of curvature. So, only its extension, seen as a dotted line, passes through the center of curvature. When an incident ray passes through the focus, it reflects parallel to the principal axis. While an incident ray passing parallel to the principal axis reflects along a line through the focus. Any ray incident at the pole will reflect back at the same angle in the opposite direction. A ray striking the convex mirror at any point will reflect back at the same angle. Here, the normal will be the line joining the center of curvature to the point where the incident ray strikes. The angle of reflection will be the same as the incident angle. Drag the candle along the principal axis and you will see that the image forms always inside the mirror. Note that the image is upright and diminished, and since it forms behind the mirror, it cannot be captured on a screen. Therefore, the image formed in a convex mirror is always virtual. In a concave mirror, when the object is placed between the pole and the focus, the image is upright and magnified. So concave mirrors are used as shaving mirrors to get a larger image of the face. The curvature is designed so that when you are within a couple of feet from the mirror, you are still within the focal point of the mirror. The tree at the intersection blocks the side view of the driver of the car moving upwards. The convex mirror placed in the northwest intersection shows the view of the west-east street, so the driver can see if a car is approaching from that direction by looking at the convex mirror rather than stretch his neck to look left. The convex mirror provides a wide-angle reflection and an upright image to avoid collisions.